Hey, what's up, everyone? This is your boy James. Welcome back to the How to Learn Data Science Python episode number 9. And today I'm just gonna keep going with the data camp like sessions, and hope you like it from the previous episode. And today we're gonna keep talking with like loading data. And this episode starting from like loading a pack files. So let's jump into it. So there's a number of data type cannot be saved easily in the flat files, such as lists or dictionaries. If you want the file to be human readable, you need to want to save them as a text file in a clever manner. JSON, which you will see in later chapter, probably in Python dictionary. However, if you merely want to able to import them in Python, you can serialize them as the meaning of, just in case you don't know serialize. Let's take a look. Serialization in computer science is the process of translate data structure or object state into a format that can be stored or transmitted and reconstructed later. So that's serialization means. And in this exercise, you will import a pickle package, open a previous pickle data structure from the file, and load it. First import the pickle import. What do we use this pickle? And then complete the second argument open so that it is loaded from the binary file. This argument will be stored in two letters, one significant read only or another binary. So what do we put over here? Kind of forgot. Open pickle from data. So what are we gonna load in? Read only. Man, totally forgot. Is that the uh, binary? Let's say first document will be two string of two letter. One signify read only, another is binary. Pass the correct argument to that. It should to the load, pickle load. You should use the variable that is the boundaries open. Oh, fine. Right. But should we store it as a string? Read only. But we figured out. Print D. The typo. Like this. I don't remember. I think it's wrong. Something. Binary. Okay, it's not binary. Read only. I think it's not right. Read. Capital. Okay, let's look at the hint. Save time. Import X, right? Letter read only binary R and B. Okay. Read only and binaries R and B respectively. To load the data into variable D, you need to support data load with the open file, which is the variable that open data pack assigned with it. Print type. Okay, so this is a function, not a method. D. Uh, bits their imprecision value start. So does that mean it should be binary? Is that they created right? Fine. Hmm. Okay, let's see the answer. I don't know. Let's see the answer. RB? Oh, just put them together. Oh, that's interesting. Really, it's RB. So first D is this one, second class dictionary. Oh, okay. So we want to generalize a dictionary. Read and the binary? Why it's RMB? I don't get it. Read only binary? Is that what that means? So obvious. I mean, like apparently over here, this first argument is the file name with the directory. Second is the what do you want to do with it? What's the attribute of it? R is read only, B is binary, and apparently you have to put two together in order to get this with open work. I assume here is like it's only not just a read only, but also it's a binary file. Well, let's go with it. And somehow it's become a dictionary. Huh, that's interesting. Well, let's just keep doing that and maybe we get more hand later. So next one, listing sheets in Excel. Okay, whether you like it or not, working with data scientists deal with Excel spreadsheet. Learn pandas, we can use pandas, and we can record spreadsheet, the dot spreadsheet name, and the spreadsheet names over here, battle dash dot Excel. Modify the Peach Research Institution like this data set. The data is the age, just mortality rates during the war, various country over several years. First, assign the file name to the variable name. Uh, File panda spreadsheet dot sheet name. What's a sheet name? A list of the sheet name using the that. So we need the site sheet name. Is that correct? Let's just run first. Port Panda. No, there's no attribute. Spreadsheet because it's missing a R. Let's see this one. Panda have no attribute spreadsheet. Okay. Wait a second. Maybe spreadsheet is name already. Spreadsheet is not defined. How about the print spreadsheet? Nope, there's not this guy. Okay. Importing to variable spreadsheet. Spreadsheet's name. Okay, the one's not right. This one. Oh, I think it's like that. Battle file. Give the variable names. And over here, you gonna use file. This is spreadsheet sheet. File Man, this is not right. Excel. Spreadsheet is not defined. Okay, let's look at hint. First, name of the file is the spread. Give this one to this file, right? Load the file by passing the file to this guy. Excel file. Oh, and then you just need to Excel the sheet names, right? Great, this is right. Okay, next, import sheet from Excel files. In the previous access, you saw Excel Excel file contain two sheets, two to four. Excel, you will learn how to import any of a given sheet and load. Um, Excel one data frame able to do some to specify each of the sheet name and index. Okay, what do you want? Import any of the sheet from load Excel as a data frame. Okay, load into data frame D1 pass. Okay, load is a pass. So you already have this. You already have this like spreadsheet object. What is this guy? It's not name is not defined. Let's first run this. Oops. So it's a panda object with a spreadsheet. Okay. So you pass it to did I just pass the name of the sheet? TF1. Man, I hope this is that easy. Let's see. Run those two. Oh really? That's it? So you just give the sheet name and then it's low. Wow, magic. So index, country name, and the year. You get that three, and then let's see. We can overwrite it. Well, actually, you gotta give a different name. But basically, like if you look at the first country, first one is like A, Argentina 36, and this one is Afghanistan. Afghanistan. Okay, 936. So you saw it's different. Okay, not right. Would you print the header? Okay, just header and set what we to do. Well, apparently it's not. Head is a function. Let's see. Oh, okay. So it's dot head. Head is the attributes. Here we go. Dot head. Customize your spreadsheet import. Well, you will pass your spreadsheet as an additional comment to skip rows, rename the column, and select only particular columns. The spreadsheet button that Excel is already loading the Excel. Before you use the method passing this time, however, you will add the additional argument to skip rows and name and the pass column. Okay. Those skip row name and columns designate which columns pass respectively. All of the argument can be assigned to a list contains the specific row number, string, and the column name. Pass the first sheet index. To do so, skip the first row of the data and the name of column country. Okay. So let's see. First one we gonna pass. What are we gonna pass? ？ over here? Skip the first row of the data in the name column. Country. Oh no, this one's a little bit complicated. So first, let's see. DFN. Oh, no. Excel. Has 4.net. Okay, so pass. What do we have here? So what do you want? Pass the first sheet index and then scoop the first row of data and name. Column using the argument name. So obvious countries is year. So pass. What are we gonna put over here? Sheet name. Which country? Pass the time in the added initial argument. Hmm. Hmm. I don't get it. Like 2004, 2002, since I have two. Skip the rows. First one. And what do you want? Name the column country. All need to be type list. Mm, that's certainly not right. Oh, that's you want to skip that. Negative? Not quite sure. Okay, let's see. How about that? Don't like it. Remove. Don't know if it's right or not. Pass the first column. Pass the first column of the second sheet. Rename it DF2. So second sheet is on 4. First column is the second sheet. What is the first column? It's country? Skip first row. Rename the column country. I'm confused. Cannot we see the answer? I have no idea how to. Okay, this one's right. To load the sheet outline names, the passive name string, and the integer respective. Let's see the answer because I have no idea. Huh? Really? Oh, pass is a parameter. First column. Oh, okay. So here you're gonna put you can put the index. All right. And here just need to put the index past the first one. Let's see what we get. The first one. Second one, just one. The first one's like. Okay, so let's look at this one. First one, second one, but it doesn't want like the string. You can pass string, and because over here, if you check it out, like you can pass string for sure. So over here, pass string, right? You load the sheet name. But over here, instead to use the string, you're gonna use the index, which respect. I mean, let's see. Okay, so you can use both, obviously. What's that? Do you probably define the df2? Yes, because I look at the answer. Country, skip row. Oh, okay. So first column is index 0. But SAS and the stat. Let's see.
There are many statistical software packages out there, and although you may not need to do so all the time, it will be important for you as a working data scientist to be able to import these files into your Python environment. The most common examples are SAS, which is an acronym for Statistical Analysis System, and STATA, which is a contraction of statistics and data. The former is used a great deal in business analytics and biostatistics, while the latter is popular in academic social sciences research, such as economics and epidemiology. SAS files are important because SAS is a software suite that performs advanced analytics, multivariate analysis, business intelligence, data management, predictive analytics, and is a standard for statisticians to do computational analysis. The most common SAS files have the extensions .stas7bdat and .sas7bcat, which are dataset files and catalog files respectively. You'll learn how to import the former as data frames using the function sas7bdat uppercase from the package sas7bdat lowercase. In this case, you can bind the variable file to a connection to the file urbanpop.sas7bdat in a context manager. Within this context, you can assign to a variable dfsas the result of applying the method toDataFrame to file. Stata files have extension DTA, and we can import them using pandas. We don't even need to initialize a context manager in this case. We merely pass the file name to the function readStata and assign it to a variable just like this. In the following exercises, you'll gain invaluable experience at importing these important file formats in Python as pandas data frames, and then seeing what was inside them. Now it's your turn. Happy importing.
Okay, let's do it. Let's do it. How do you import SAS7B dat? Import SAS7B dat from this one, this one. What? Oh, from. Really? I mean, like three times wrong. From small one, import the variable name small, library name uppercase. Remember that. Okay, import SAS file. You figure out how to import SAS file using system that this guy. I'm not even gonna try to pronounce that. It's already in your work directory, and the pandas, matplotlib, pyplot have already been imported. Okay. From lowercase SAS7B dot import SAS7B dot SAS7B dot. Wait, is this a variable's name? Hmm. File. Import the file. Okay, what I'm just gonna put over here. Oh, this library is small, and this is a variable name, so uppercase. My bad. In the context of the file, cellsas7b dot load its content into data frame. To data frame print. So you basically opened this guy as a file. So variable name df sets, right? Equals to panda. Because already loaded variable over here. It's a listener container or container, I think he said. To it's already there, so you can just convert to data frame file, and you print the header, the head, not header, and then plot it. PD data frame hist SAS P. I think it's it's like column name. Pandas don't attribute to data frame. Interesting. Look at the hand. File dot. Oh, okay. So it's file, not the pandas. Yeah, because the file have the two data frame function. Import module A and B file, and this is the result when you use the two data frame object file. And of the data is printed, and I have to change the code and the hist data frame hist and put it There P. Oh, good. What is this? Count. Okay. Looks good. Principle of economics. Okay. Good. Use read data to import to data files. Panda package had been. So by the way, previously the Panda is actually using to load the matplotlib. So you need to have the Panda to kind of like to lead to the matplotlib to just print it out. You can just not just print that data frame from the SAS object converted data frame for some reason. You have to use Panda. But we learn more from that. Maybe I'm wrong, but we see how it turns out. So use read data to import data files. The Panda package has been imported to the environment as PD, and the file disaster DTA is in your work directory. The data consistent. That's the content of several disasters in the various countries. What is the correct way to use the read data function to import this data into object df? Okay, Panda do obviously C. Let's see. Oh, great, yes. Yoga expertise in import the data file as a data frame using the PD read data function from pandas. The last access file disrasa DTA is still in your work directory. Use panda read data to load the disaster. Okay. Df equals panda read data and this DTA print the head and that right print PD. Let's just type it and just try to memorize this. Data frame. The hist EF. What's it like? List and list is kind of like the access a cell. SA10. And the PLT X label. Extend of disaster. Oh, there's Y labels over here. Good. PF. What is PF? PD. Panda PD. Okay. Extensive disease and number of countries. Oh, okay. Okay. Interesting. So it's got countries and it's a white data frame. Oh, HDF5.
According to the 2013 O'Reilly book, Python and HDF5 by Andrew Collette, in the Python world, consensus is rapidly converging on hierarchical data format version 5, or HDF5, as the standard mechanism for storing large quantities of numerical data. Now, how large are we talking here? According to Collette, it's now relatively common to deal with datasets hundreds of gigabytes or even terabytes in size. HDF5 itself can scale up to exabytes. Let's explore with a concrete example from LIGO, the Laser Interferometer Gravitational Wave Observatory project. You first import the package h5pi, and then import the file using h5pi.file, remembering to use R in order to specify read-only. Printing the data type to the shell reveals that we are dealing with an h5pi file. But what is the structure of this file? You can explore its hierarchical structure as you would that of a Python dictionary using the method keys. You see that there are three keys: meta, quality, and strain. Each of these is an HDF group. You can think of these groups as directories. The LIGO documentation tells us that meta contains metadata for the file, quality contains information about data quality, and strain contains strain data from the interferometer, the main measurement performed by LIGO, the data of interest. If you knew what data and metadata should be in each group, you could access it straightforwardly. However, if not, due to the hierarchical nature of the file structure, it is easy to explore. For example, let's say you wanted to find out what type of metadata there is. You could easily print out the keys. Now you know the keys, you can access any metadata of interest. If you're interested in description and detector, all you need to do is print out the corresponding values. You see that the data in the file is strain data time series from LIGO, and that the detector used was H1. Next, perhaps, you would like to check out the actual data. Great idea, and that's precisely what you're going to do in the upcoming exercises. Before you do so, it is also worth noting that the HDF project is actively managed by the HDF Group, based in Champaign, Illinois, and formerly part of the University of Illinois Urbana-Champaign. Now it's time for you to import and visualize some of the data that led to the validation of Einstein's theory of gravitational waves. Enjoy.
Wow. Let's see. Okay, use file to import the HDF5 file. First, import package h5py. Second, the file LEGO data HD5 file is loading the object HDPY file. What is the correct way to use h5py function? File and import file to the h5py file into object for read only. So this is a package, right? So object read only h5py dot file. I think it's second one. Yes. Use h5py to import HDF file. Okay, man. Import h5py, and you will print out this data frame comfortably. Import it correctly, you will then study the structure of the file in order to see the precise what HDF file group is contained. You can find the LEGO project to plot the load of the documents and the tutorial here. Okay, also grid tutorial to signal process of data here. Let's do that. Let's not do that. Assign file name to file. h5py. File name. Oh, it's probably not right. Yet no attribute of file name. It's a period. Hmm. I don't know this one. And put the file. I think it's print out data type. Print data. Wait a second. That's fine. Oh, okay, here. Name. Like this. NumPy.name. Do we have a NumPy.name? Fine. Well, let's see. Well, let's look at the hand. First, import the package. Name of file. Name of the file is this guy. Okay, I got this right. Make sure to pass the file as the first argument, R as the second. Okay. Oh, is that file name? You mean this? Why do you need the NumPy? Oh, okay. Print out the key. And in order to print the key, why you can imitate of them for like why data uh, keys. So print out. Let's see. Print out data. Oh, okay. Load array. Print out type. PY and then for keys in data keys. Data keys, right? Okay. Data keys. That's probably why we need a loop here. Meta quotients. Stain. Great. Wait, what's wrong? Great. Extract data from your HD5 files. Index as UL. Extract some of the Lego experiment actual data from the HDF file. You will visualize them. To do so, you need to first express the HDF5 group as stain. Okay. To get the 5 group, assign the stain to group. Oh, this one's okay. Right here. Data found keys. Okay, got key. Okay. Then group equals to get the groups. Data equals pass string key in the group keys. Oh, the dimensions, right? What do we have here? Oops, nothing. Set variable equal to time series data string. Name sample number of samples equals to 1000. Wish to sample and extract the rest of the code to produce a plot of time series data. Set variable equals to time series. Number of times. String the variable time series data. Oh, uppercase. Previous one is lowercase, so it's so the column names or the key names in this column in this metadata. Well, what's the structure? Let's visualize it. HDF file structures. This is probably help us to understand what that looks like. Imagery. Set minus. Okay, that makes sense. A lot of like big stuff with small stuff. So it's like a data framing, if I understand that right. An example of HDF file structure contain data of multiple field sizes and also contain variable data sets. Okay. Group, meta, dataset, meta. Okay. Well, I think it makes sense. Oops. Close it. Okay, here, so data, right, it's kind of string. String. What is string? It's stuff string. Okay. So we got this one. And then let's plot it. Ooh, that's cool. What is time? And range 0115 frequency. I think. Okay. So for data sets of like from 0 to 1, my sense is yes, I think so. 0 to no, it's 3 decimal. 0, 0, 0. Plot times. String. Everything to 1000 times GPS. Y and show. Wow, this is awesome. Oh, first southern row? Let's try it out. What do we have here? Oh, very small number. It's a list. Yeah, it's a list. Okay, string's a list. Okay, what? Did you set character to string? Yes, I do. Oh, value. Wait, so what do we have this? RDE data set, it's a whole thing. The string is over here. Okay, now it's array. Run everything again, get the same results, and submit. Do you set correct the value to number of sample? Yeah. Oh, 10,000. Wow. Whoa. Why there's a 2 graphs over here? I guess I'm just gonna copy this one, refresh this page, because I don't know why there's a 2. From thing. Oh, here we go. This one looks more right. Because you got 10,000, you got more frequent over here on time series in this list time step GPS and string. Ta-da! Import MATLAB.
MATLAB. is short for Matrix Laboratory, is a numerical computing environment that is an industry standard in the disciplines of engineering and science. This is in part due to its powerful linear algebra and matrix capabilities, in part to its proprietary nature, and in part to how difficult the academic world finds it to shake off old habits. Regardless of the reasons for its widespread use, the fact of the matter is that a lot of people use MATLAB and save their data as .mat files, the file format native to MATLAB. Now, how can you import these into Python? Luckily for us Python aficionados, the standard library SciPy has functions loadmat and savemat, which allow us to read and write .mat files respectively. What exactly is in a .mat file, you may ask? To answer this, let's look at the MATLAB IDE. In particular, check out the MATLAB workspace, where all your variables are stored. This workspace can contain strings, floats, vectors, and arrays, among many other objects. A .mat file is simply a collection of such objects. Now, this means when importing a .mat file in Python, we should expect to see a number of different variables and objects. In this code, I first import scipy.io and then load the file workspace.mat. Checking out what type of object results tells me that it's a dictionary. How this dictionary relates to a MATLAB workspace is straightforward. The keys of the Python dictionary are the MATLAB variable names, and the values of the Python dictionary are the objects that are assigned to the variables. In the above example, MATX is a NumPy array corresponding to the MATLAB array X in your MATLAB workspace. It's that easy. Now it's your turn to import a MATLAB workspace array
Let's see. The key is the MATLAB variable names, variable object is sent to the
X in your MATLAB workspace. It's that easy.
All right.
Now it's your turn to import a MATLAB workspace and check out what it contains. Happy exploring.
Let's see. So load mat files. In this exercise, you figure out how to load a MATLAB file using a scipy.io load mat, and you will discover Python data type it uses. In this, I'm not gonna pronounce that .mat file in your work directory. This contains of string expression data. Okay, UC Davis. You can find the data here. Import. Let's first import scipy.io. Oh man, do you guys remember that syntax? Like mat equals to do. So if you don't import as something, so you just use the variable names. io.mat, load mat. Here, put the let's type it. Back G ration .mat. Print the data type of the mat. Type mat. That's right. Good. The structure of .mat Python. Here you discover the mat dictionary that you load in the previous exercise. You already load this 3 libraries: scipy.io, matplotlib, pyplot as a plt, and numpy with np. First, what are we going to do? Print the key of MATLAB directory. Print, I remember the keys of the mat. Did we save as mat? Okay, we do. So what is that? What Hugo said? Like the key is the variable name, so the values variable name. Key is the what is key? What he said over here? Do you guys remember what he said over here?
Space.
Okay, key is a MATLAB variable name. Value is object assigned to the variable. Variable name. Value assigned to variable. Okay, have a equation. Okay, equals to value. All right. So let's see. Print the keys, right? Print the key, no big deal. Okay, so you got a whole bunch of keys over here. MATLAB. So, variable name, variable wheels. Okay, value. Print the type of the value corresponding to the key. Once effectively do not begin with the dash. Our variable from the corresponding environment. Print the type of variable corresponding key. This guy in math, we call math something. Okay, so you can just math value of cy rat ratio cy t. Is that cryptocurrency value? Obviously, I spell this uppercase Mac. Mac, 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 Mac. Print the shape of the value corresponding of that shape. What is shape? Numpy function shape. Okay. Mat. So mat. Y ratio. CYT. Shape is not defined. Yeah. Shape. Okay, let's skip that. Execute and receive the all cylinder J expression data. Okay, here. Shape. Let's see. Oh, because we print. I think that's probably why. Print shape. Oh, let's look at the hint. Oh, numpy shape. So numpy function. So where is that over here? Good. The whole thing. Ooh, that's cool. So print down value. So data equals to this one 0 to 25 rows. What is data looks like? Let's take a look at that. It's not array. What is this? Right? So first, this is array, right? Oh, it's an array in array. Okay. First 25 row. Oh, wait a second. This is crazy. Man, I realized that. So it has 200 row, 137 columns. And here is 26 rows, 5 column in beyond. Is that what it is? Why it's a list? Well, we're gonna do some reminding exercise later for why this one coming with a list rather than a data frame. And then you got the plot figures, you got plot data, X label, Y labels, show. Well, this is pretty cool. Print function that get the type. Where's the time? Oh, okay. One times over here. One times over here, not the column itself. Okay, NumPy array. It's settled. Good. So I guess this next episode is introduction for relational database. I think it's gonna be very interesting. But I hope you enjoyed today's episode, and I see you next time. Peace. I think I'm click here.